Hello, so welcome to this video. So I'm just moving my headphone a little bit, which will hopefully improve the sound quality. I released this video before, but there were some sound quality issues, so I'm really hoping this time the sound quality is resolved, at least for the time being. So this video is about tachyons and time travel and how they break causality. We'll be looking at how, whilst the passage of time might be a relative concept in relativity, no pun intended, causal time is preserved if we're not worried about tachyons. If we are, tachyons might allow effects to come before the causes of those effects occur. So that can lead to some massive headaches for physicists, which is one of the reasons lots of physicists do not like tachyons. I personally am much more open to them, but that's my own personal preference. So for a tachyon and how it affects time, we have to understand something about the order of time if we're not worried about tachyons first of all. So to understand time and how different observers perceive time, we need to refer back to the Lorenz transformation matrix, and it describes how the components of a four-vector can differ from one observer to another, and we model that as kind of the space-time axes observers are using to measure the components of a four-vector in space-time being angularly displaced from the space-time axes in a different reference frame. And that way we can get things like the time-like component of full position, which turns out to be the time interval between events, can differ from one observer to the other. We've seen that when we looked at time dilation, and muons particularly taking a lot longer to decay when they're moving very quickly, as they are when produced by cosmic rays, than if the muon was kind of stationary relative to us. So we talked about the passage of time, or the amount of time that has passed, not being preserved under Lorenz transformations. In other words, different observers may disagree on the time interval between events. We haven't much talked about the order of events. Well, provided we're not worrying about tachyons and we're sticking with events, say within our own light cone, or more generally, events for which the space-time interval separating them is positive, so ds squared is bigger than 0. For these kinds of particles, for these kinds of events, if you say that event A happens followed by event B, then any other observer moving relative to you, providing they're not moving at the speed, providing they're not moving faster than the speed of light, will also agree that A happens and B happens. And the importance of this is if two events have a positive space-time interval, or using more technical language, we say they're time-like separated, then it is possible for event A to send a light beam to influence event B, because they're separated by distance in space-time such that light can kind of bridge the gap from one event to another. And that means for time-like separated events, there's a possibility that those events are causally related. A could have affected B. And so Lorenz transformations act, providing we're not worrying about velocities faster than the speed of light, they act to ensure that the passage of causal time is preserved. So if you say event A happens, then event B happens, then even if I move relative to you at half the speed of light, I will still agree that A happens, then B happens. And I certainly won't say B happens before A. But that's if we're worrying about causally connected events. What happens if we're not? What happens if we're looking at events which are separated by space-like space-time intervals for which ds squared is going to be negative? Now these events are events such that light couldn't have travelled from one event to the other. There's simply not enough time has passed. And that ensures that providing we ignore tachyons, these events cannot be causally related. And it turns out when the events can't be causally related, due to assuming that there's nothing that is travelling faster than the speed of light, relativity and particularly the Lorenz transformations say, well, actually, the order of events can be different in one reference frame to another. So if A and B have space-like separations, you could say, well, A happens, then B happens, but I might say, well, I think B happens and then A happens. But that's fine, that doesn't lead to any paradoxes, because the causal structure of time is preserved because A and B are not causally related. And the thing is with the tachyons, because they travel faster than light, suddenly these space-like separated events are causally connected, or at least have the potential to be, meaning now there comes into the possibility that if we're allowing, say, tachyons to be emitted from a gun being fired, and we call that point in space some event A, and then say hitting someone is event B, well, because the tachyons are moving faster than light, we're now in a situation where some people might say that the tachyon bullets hit a person before they were even fired from the gun, because now these causally related events, these space-like separated events, the order is no longer preserved. And the order wasn't preserved even without tachyons, it's just without tachyons these events are not causally related, so there's no issues with that. Now what we're going to do is we're going to try to prove that formally using some mathematics. So if we can prove it mathematically, let's consider two events. To make things, as straightforward as possible, let's say that these kind of two events are occurring on a tachyon, or for a tachyon particle itself. So let's say we're looking at two events. One event, a tachyon is produced at some point in space, it then travels faster than the speed of light, and at some other point in space it decays. And we're going to prove that if we look at the time interval between these two events, and we say for us that this time interval is positive, so the zeroth component of full position relating to full position between these two events, the tachyon being created and the tachyon decaying, is bigger than 0. Then providing this tachyon is moving faster than the speed of light, which it must because it's a tachyon, the tachyon will actually say that there's a negative time interval between these two events. So for example, if we said the tachyon seemed to be, created and then decayed, the tachyon would think it's been decayed and then created. Or if we flip that around, if the tachyon thinks it was created and then at some point later decayed, we would see it decay first, and then only after would we see it be created. Essentially, there's what we see is going into the future. So what we assign a positive time interval to, the tachyon assigns a negative time interval to. So it sees in the past, and vice versa. Well, if we could prove that, then we first look at our Lorenz transformation, which is our 2x2 matrix, which relates the components in the non-prime reference frame, so the components for us, the stationary observer, to the components of 4 position for the prime reference frame, so for the tachyon. And because we're interested in relating time intervals between the tachyon's reference frame and our reference frame, we're not interested in xi prime, we're just interested in x0 prime and its relation to kind of the components of 4 vector from our perspective. And using the Lorenz transformation, reading directly from our equation, we can see using matrix algebra that x0 prime is equal to gamma, the Lorenz vector, times x0 minus beta times gamma times xi. Well, if x0 is bigger than 0 and x0 prime is less than 0, then we can just say therefore that gamma times x0 minus beta times gamma times xi is less than 0, and now we can do a bit of mathematical trickery to simplify this. So firstly, we can bring the beta gamma xi to one side of our equation, and then we can divide both sides of the equation by the Lorenz factor gamma. Because the Lorenz factor is a number, as we saw in our previous video, that number happens to be imaginary, but it's still a number, it's not a matrix, so there's no complexities with dividing it. And that way we get that x0 has to be less than beta xi. Now, to simplify this further, we're going to use a very specific description we gave, that we're talking about events that happen for the tachyon itself. And xi is how far apart these events are in space from our perspective. But how far apart they are in space is just equal to the time interval that has passed between the events from our perspective times the speed the tachyon is moving at. It's just distance equals speed times time, but making sure it's all in one reference frame. And then using that, we can just rewrite it in terms of our beta factor and go the spatial distance between the events xi is just beta times x0. Therefore we have that if we substitute that into the top equation on the right hand blue box, we get that x0 has to be less than beta squared times x0, and that's obviously going to happen when the size of beta is bigger than 1. In other words, when our tachyon is moving faster than the speed of light. Now, we've essentially here gone, well, if x0 is positive and x0 prime is negative, then beta has to be bigger than c, but we can reverse it. You could go, well, if x0 is positive and and v is bigger than c, then x0 prime is going to have to be negative. So in short, we've shown that the order of the events that the tachyon perceives happening is going to be the opposite to the order of events that we see happening. So to summarise why, the problem of events which have space-like space-time intervals not having a universally agreed upon order is problematic when we consider tachyons, but otherwise isn't an issue at all, or at least doesn't lead to any paradoxes, even though it might lead to many headaches. Well, as we said, if we're ignoring tachyons, then the fastest speed that information could possibly travel theoretically is the speed of light. And that means if two events are so far apart in space that they cannot be, that there hasn't been enough time for light to go from one event to the other, they are not causally connected, and therefore they are to a large extent independent, and therefore there's no causal structure broken, there's nothing fundamentally gone wrong if the order of those events depends upon the reference frame of the observer. It would be a problem if the two events were closer together and close enough that information could be transferred between them, but they're so far apart that not even light can get from one event to the other, then having an unclear direction of time is not problematic. However, tachyons, because they travel faster than light, could allow communication faster than light, therefore allowing events which have space-like space-time intervals to be causally connected, meaning that if tachyons exist, the causal structure of time is not invariant. We would see tachyons acting as if they're going into the past in a very causal way, and that might lead to plenty of paradoxes. Like if a tachyon egg fell to the ground, you would see it break on the ground, then rise up into the air and reform itself, creating havoc with things like entropy and the second law of thermodynamics, etc. However, it's worth saying the second law of thermodynamics tends to presume a direction of time to begin with, so it's highly contested whether actually the second law of thermodynamics assumes a particular flow of time, or whether it can be used to argue whether a theory that says that the flow of causal time is relative could actually be valid or not. The second law of thermodynamics might simply be wrong because it has a wrong assumption at its core. Possibly. It's still very much debated exactly how fundamentally to think about the second law and the assumptions within it is very much a debated topic. But we've seen through this playlist that time is relative. We've seen it through time dilation. We will see it through talking about simultaneous events in space-time. And the fact that there's no such thing as a universal ideal of now. We talked about it here in terms of, for, space-like separated events, there's the notion of past and future is relative and depending on one's reference frame, but now we've discussed that if we include tachyons into the picture, then the relative, time, the relative passage of time in terms of causal time itself and the structure of cause and effect might also be relative. So time is a very, very fuzzy and strange thing in relativity. But now we've talked about that, it's worth saying in the next video I will talk about imaginary time and the fact that the Lorenz vector is imaginary, building on the previous video and trying to understand what we mean by imaginary time, before moving on to talking about kind of the quantum mechanics of tachyons, which will neatly wrap up the tachyon part of this playlist. But before we do this, it's worth revealing a mystery which I've heard before in my life, and has also kind of like it's a mystery which is still present, and I would like to share with some of you with the community. So the thing I would really kind of like to share is kind of like throughout my life, at various points, people have wondered the origins of my voice. Uh, I would like to now kind of confess where the sound of my voice comes from and resolve this mystery. So if anyone wonders, this video will present good clarity. So I would like to show you what is very clearly firm and unquestionable photographic evidence of why my voice is rather high. So this is what I get up to on a daily basis, and as you can clearly see, here I show me breathing in helium from the sun, from the chromosphere of the sun to be specific. Now, the sun contains a lot of helium, and the benefits with learning to breathe helium is, one, helium is a noble gas and therefore isn't reactive, so it's perfectly safe to breathe. The other thing is, if you learn to breathe helium, you will not be, hopefully, reliant on oxygen, meaning you might survive extensive deforestation if the human species continues destroying the trees, and therefore diminishing the amount of oxygen available in the atmosphere. So it's a very beneficial activity to breathe helium, and here you can see me doing it, something I genuinely do on a daily basis. So, worth recapping the benefits of breathing helium. For those of you who would like to do something similar, it's worth saying. A challenge I found was storing the straw in my parents' shed, because, as you can imagine, the straw had to be very long. In fact, it had to be one astronomical unit long, because it had to reach all the way from down here to the surface of the sun, which is a very, very long distance. But thanks to length contraction and special relativity, because my parents' shed happens to be moving close to the speed of light, storing this contraption there was possible. It has a very different length when it's relative to me compared to when it's moving close to the speed of light. So this is how I gain my voice. I actively and very diligently breathe helium and take it from the sun, as you can see. Clear evidence, undisputable evidence, which is completely genuine through this part of the video. So now we've kind of like recapped the mystery of my voice and the benefits of building a straw to reach from the earth to the sun. It's worth saying in the next video I will talk about imaginary time. I will also have a challenge for you, so if you like tachyons and enjoy this channel, you might like the kind of challenge I've got for you at the end of that video. But this is everything for this video. As always, wish you a very good day. I hope you enjoyed the content. If you're new to the channel, please consider subscribing, helps the channel out, helps it grow, and so forth. And as always, have a good week, stay curious, have a lot of fun, and hopefully see you for another video soon.